All right, so let's do this question about Yoshi from the Module 5 problem set, or Module 4 Lesson 5 problem set. It says that she's 5% taller than she was last year, and she's currently 168 centimeters tall. So how tall was she last year? So another way you could say this exact same thing is her current age is 105% of, sorry, not age, height. Her current height is 105% of her height last year. Right? If you increased 5% from some previous quantity, then you now have 105% of that quantity. And so if you wanted to do this one algebraically, you could just set up the equation 168 centimeters, her current height, equals 105%, so that's 1.05, times whatever her previous height was. So we just make a variable x to be her previous height. And then you would divide both sides by 1.05 to get that x all by itself, and you would get 160 equals x. So her previous height was 160. But this module is more about like how do we do this stuff with double number lines and using manageable chunks and figuring out, without doing it this algebraic way. So let's look at that. Let's make a number line. And I think it usually works best if you make one of the number lines relative to the quantity you're trying to figure out, not the quantity that you know. And so what I mean by that is this line here and the next one I make are both going to be in terms of her previous height, not her current height. So I'll write her height here. And then the information that we know is, well, this bar can go from 0 to 168, which is, I guess you could call this current height. But the one that we're trying to figure out is somewhere a little bit to the left of this, right? Not by much, because she's only 5% taller now. And so the height that we really want to figure out is somewhere around here. And that's sort of like the important thing. Because when we make this the second number line, the one that is going to be representing everything in percents, well, we could have 0% of her height, and her current height is 105% of the height we're really looking for. And so the one that we want, that's where we're going to write 100%. That's what I was trying to say a moment ago when I said let's make it relative to the thing that we're trying to figure out, right? The quantity that we're trying to figure out is where we want to line up 100%. Now, we want to think about what manageable chunk can we use to solve this. So, or in other words, what factor of 100 can we easily find given 105%? Well, there's no good way to take 105% and turn it into 25% or 20 or 10, but we can get it to 5% because 105 divided by 21 equals 5. So in other words, if we take this number here, the 168, and divide it by 21, I'm going to write divide by 21 right here. Then we do the same thing to 105%. We divide it by 21. And what will wind up over here is 5%. Where do I want to write that? I'll write it right here, 5%. And then whatever we wind up on top, 168 divided by 21, that will represent 5% of her previous height, the number that we really want. So let's do that. 168 divided by 21 Well, I know that if it was 160 divided by 20, I'd get 8. So that means 1 more 8 would give me 21. So yeah, I think it's gonna be 8. All right, so 8. So 8 years represents 5% of 100%, which is her previous height. And so now all we got to do is, since if you wanted to take 5% and take it to 100, you would, let me use this other color down here. You would have to multiply by 20 to get back to 100%, right? So we got to do the same thing up here. Let's take this 8, multiply it by 20, and we will get what number goes here. 8 times 20 is 160. So the overall strategy was divide by 21 to get down to 5%, but then multiply by 20 to get back to 100%. And the reason that kind of works is because it all boiled down to the fact that she was 105% of her previous age, right? Well, 105% can be written as 21 twentieths as a fraction. But the 21 is on the top and the 20 is on the bottom. And what we did is sort of like the opposite, because we divided by 21, which is usually represented by the number on the bottom of the fraction, and we multiplied by 20, which is usually represented by the number on top of the fraction. So what's happening that's opposite here? Well, let's go back to this equation here. Remember that we wrote 168 equals 1.05x, but 1.05, that's the same thing as 21 twentieths x. And now if we wanted to solve this equation, we would divide both sides by 21 twentieths. And to do that, 168 divided by 21 twentieths, we would keep change flip and do times 20 over 21. But that's just the same as 168 times 20 and then divided by 21. And that's the solution strategy we wound up using. But we just did it in this sort of roundabout way using number lines. So what we're really doing is taking like a decimal algebraic solution and turning it into a more number sensey, fraction, keep change flippy kind of way of doing things. All right.